So let us start now. Last class I have given a homework. This was homework. They give an example. This give an example of a function which does not satisfy the conditions of Rolle's theorem, but yet there exists value of C. We shall give example. We shall give example. Solution is this. Fx is equal to, I write this, Fx is equal to 1 by x plus 1 by 1 minus x in closed interval 0, 1, in closed interval 0, 1. We shall show that this function does not satisfy the conditions of Rolle's theorem, but still we get value of C. You have to keep this example in your mind. We shall show that this. Here, number A, this function is not continuous at x is equal to 0 and at x equal to 1. Here, at x equal to 0, function is not defined. At x equal to 1, it is not defined. Fx is not continuous. Fx is not continuous at x is equal to 0 and x is equal to 1. Number B, f dash x is equal to, what is its derivative? Minus 1 by x square plus this derivative is again minus 1 by 1 minus x whole square, and derivative of 1 minus x is equal to minus 1, which exists in open interval 0, 1. And number C, f of 0 is not equal to f of 1, both being undefined. Therefore, fx does not satisfy the conditions of Rolle's theorem. But f dash c is equal to 0. This means minus of 1 by c square plus 1 minus 1 by c whole square is equal to 0. We are getting this thing 1 by 1 minus c whole square is equal to 1 by c square. So this will give you 1 minus c whole square is equal to c square. 1 minus 2c is equal to 0. C is equal to 1 by 2. This lies between 0 and 1. 0 and 1. Therefore, I write this. Therefore, fx does not satisfy. The conditions of Rolle's theorem. Fx does not satisfy the conditions of Rolle's theorem, but there exists C. But there exists C. Now we shall start Lagrange mean value theorem. I লেখো heading the Lagrange mean value theorem. Lagrange mean value theorem. Lagrange mean value theorem. A statement লেখো let fx be a function. Let fx be a function defined in closed interval AB such that number one fx is continuous. Fx is continuous on closed interval AB. Number two, f dash x exists. F dash x exists in open interval AB. That means these are conditions of first two conditions of Rolle's theorem. Conclusion লেখো then there exists at least one value of x. Then there exists at least one value of x, say small c, in open interval AB such that f dash c is equal to f of b minus f of a divided by b minus a. So this is Lagrange mean value theorem. Lagrange mean value theorem. And in Rolle's theorem, what was the third condition? Third condition was f of a is equal to f of b. And if I put here f of a is equal to f of b, then we get f dash c is equal to 0. So that means Lagrange mean value theorem is a particular case of Rolle's Rolle's theorem. Rolle's theorem is particular case of Lagrange mean value theorem. In Lagrange mean value theorem, f of a may or may not be equal to f of b. If f of a is equal to f of b, then this theorem reduces to Rolle's theorem. So I can say that Rolle's theorem is a particular case of Lagrange mean value theorem. I clear, student, what I want to say? Is it right?
Yes, sir.
Yes. Lekho. I proof lekho. This proof is important. I proof lekho. Lekho. I proof is this proof. Let if f of a is equal to f of b, like if f of a is equal to f of b, then this theorem reduces to Rolle's theorem. Therefore, we shall prove this theorem. We shall prove this theorem when f of a not equal to f of b, f of a not equal to f of b. Aileko, let us consider let us consider a function capital Fx is equal to small fx plus a into x in closed interval ab, where capital A is a constant, capital A is constant, and we shall determine sorry, and we shall determine capital A in such a way that f of A is equal to f of B. So what does it mean? That means capital A is a constant such that f of A is equal to f of B. Capital A is a constant such that f of A is equal to f of B. Now, like, now from this equation we shall find value of A. Like, now f of A is equal to f of B. This implies f of A money. It is f of A plus capital A into A is equal to f of B plus capital A into B. From here we get capital A into small a minus b is equal to, it is f of b minus f of a. So this implies capital A is equal to, I can write it as, it is f of b minus f of a divided by minus of b minus a. And this is number one. This is number one. Now, so we are getting value of capital A. Now I shall show that capital Fx function satisfies all conditions of Rolle's theorem in closed interval AB. Leco, number A, first is this, number fx is, small fx is continuous, it is given, and x being a polynomial, it is continuous, and sum of two continuous function is also continuous. We shall write here, lekho, since fx and a into x both are continuous, on closed interval AB. Therefore, capital Fx Therefore, capital Fx is continuous on closed interval AB. So we are getting capital Fx is continuous on closed interval AB. Number B, capital F dash x is equal to, it is its derivative. This is small f dash x plus capital A. In this theorem, it is given that f dash x exists. So f dash x exists and A is constant. So that means capital F dash x exists. Lekho. So f dash x is equal to this, which exists, which exists in open interval, in open interval AB. And third condition, number C, here f of A is equal to f of B. Here we have already assumed this f of A is equal to f of B. Therefore, capital Fx satisfies, capital Fx satisfies all conditions of Rolle's theorem, all conditions of Rolle's theorem in closed interval AB. Therefore, therefore, there exists at least one value of x. There exists at least one value of x, say small c, in open interval AB, such that f dash c is equal to 0, which implies here f dash c mane from this line it is f dash a, sorry, it is f dash c plus a is equal to 0. So this implies f dash c is equal to minus a, and which is equal to minus a. Just put value of a here. So if I put value of a here, it is f of b minus f of a divided by b minus a. I hence prove. Any problem, student? Do you have any problem? Any problem?
No, sir.
Okay. So this is the proof of Lagrange mean value theorem. I next lekho Cauchy's mean value theorem. Cauchy mean value theorem. Cauchy's mean value theorem. I statement statement lekho Cauchy's mean value theorem. Lekho, let fx and gx, Here I need two functions. Lekho, let fx and gx be two functions defined in closed interval a b such that such that number one first condition lekho fx and gx both are continuous on close interval AB. Number two, f dash takes and g dash takes exist in open interval AB in open interval AB. Third condition is this. Third condition is this. G dash x is not equal to 0 for all x belongs to open interval AB. মানে g dash x is not equal to 0. G dash x is not equal to 0 for any x in open interval AB. Conclusion is this. লেখো then there exists at least one value of x, say small c, in open interval AB such that here we get this thing such that write this such that f dash c divided by g dash c is equal to f of b minus f of a divided by g of b minus g of a. G of a. I দেখো here I just listen me, do not write it. I listen me, do not write it. দেখো here fx satisfies both the conditions of Lagrange mean value theorem. So for fx you can find f dash c in this way, and similarly gx function is continuous, gx is differentiable, so g function also satisfies all conditions of Lagrange mean value theorem. So for g function also you can find in this way to g of b minus g of a divided by b minus a. And if you divide both, then you can find this expression. But this is actually not the fact. It is not true. Why not true? Because for f function value of c and for g function value of c are not same. That is why Cauchy's mean value theorem will have independent proof. So I shall now again prove this theorem. This theorem actually I shall show here, but it is your homework. I do not write it. Just look at the board. How can I prove this? And you will write this thing. I look at the board. देखो, this proof is your homework. You will do this. Look at the board. We shall start from here. Let us consider, and every sentence in this proof will be same. Just you will change here. Look at the board. I shall send you this. Let us consider a function fx is equal to small fx plus a into gx, where f of a is equal to f of b. Now f of a is equal to f of b. This will give you f of a plus a into ga plus a into gb. So from here we are getting this is a into g of a. This will be g of b. This. So from here we get capital A is equal to this g of b. This will become g of a. And same thing here. The since fx and a into gx both are continuous. Here it is given fx and gx are continuous. So since fx and a into gx are continuous on closed interval ab, so capital Fx is continuous on closed interval ab, and f dash x will be equal to small f dash x plus a into g dash x, which exists in open interval AB, because here it is given that f dash x and g dash x both exist. And third condition, f of a is equal to f of b, it is given. We have assumed. So therefore, capital F function satisfies all conditions of Rolle's theorem in closed interval AB. Therefore, there exists C such that f dash C is equal to 0. So this will give you f dash C, mane this is small f dash C plus this is a into g dash C is equal to 0. So here we get f dash C divided by g dash C is equal to minus a, and value of a is equal to this. So I can put here g of b and it is g of a. I clear, student? Is it clear? Subro, is it clear? Subro, any problem?
No, sir.
Deopriya, any problem?
No, sir.
Protusa, do you have any problem?
No, sir.
Okay. Amrita, any problem?
No, sir.
Spandan, do you have any problem? Spandan, Spandan, do you have any problem? Ritavan, any problem?
No, sir.
Next, lekho. So you will just copy this. I shall send you, or you can take the screenshot of this thing. I just take a screenshot. You will write this, and every sentence will be same. Next, lekho. Now question, lekho. Now question. Question, lekho. Have you done this in your college? Have you done this in your college?
Yes, sir. Yes, sir.
Done. Okay. Ahí lecó, question lecó, question lecó. If f dash x, question is this. If f dash x exists in closed interval 0, 1, if f dash x exists in closed interval 0, 1, then so by Cauchy's mean value theorem, so by Cauchy's mean value theorem, the equation, the equation f dash x divided by 2x is equal to f of 1 minus f of 0 has has at least one solution, has at least one solution in open interval 0, 1, open interval 0, 1. Here it is given that here it is given that f dash x exists in closed interval 0, 1, and also it is given that you have to use Cauchy's mean value theorem. Cauchy's mean value theorem to show that the equation f dash x divided by 2x is equal to f1 minus f0 has at least one solution in open interval 0, 1, in open interval 0, 1. So in Cauchy's mean value theorem, I need two functions. Here one function fx is given. Then first question is what will be gx? What will be gx? Can you say anyone what will be gx?
Sir, x square.
Sir, x square.
X square. Gx will be x square because this is actually g dash x. So it is g dash x. Its integration is x square. So first write this. Let us consider gx is equal to x square in close interval 0, 1, in close interval 0, 1. Also, I shall use another result we have done in previous semester. If a function is differentiable, then it is continuous. Here f dash x exists, money it is differentiable. So we can say that fx is continuous. I write here, since f dash x exists, since f dash x exists in closed interval 0, 1, therefore fx is continuous. Fx is continuous in fx is continuous on closed interval 0, 1, and gx being a polynomial and gx being a polynomial, it is continuous. Gx being a polynomial is continuous on closed interval 0, 1. Next लेखो, next लेखो, f dash takes a second condition, f dash takes and g dash takes is equal to 2x, both exist in open interval 0, 1. Both exist in open interval 0, 1. Now third condition, the g dash x is equal to 2x. It is clearly not equal to 0 in open interval 0, 1. And this will be equal to 0 at x equal to 0. But here it is open interval, mane 0 is excluded. So this is not equal to 0 in closed interval 0, 1. So that what does it mean? That means this function satisfies all conditions of Cauchy's mean value theorem. Lekho, therefore, conclusion, therefore, there exists at least one value of x. There exists at least one value of x. Say small c in open interval 0, 1. In open interval 0, 1, such that f dash c divided by g dash c is equal to f of 1 minus f of 0 divided by g1 minus g0. So this will give you, this will give you f dash c, f dash c divided by g dash c, money it is twice c is equal to f of 1 minus f of 0. A g of 1 money it will be 1 and g of 0 money 0. So denominator is ultimately 1. And what does it mean? What does it mean? This means c is root of this equation. Lekho. This shows that this shows that small c is root of the equation, is root of the equation, root of the equation, this equation f dash x divided by 2x is equal to f of 1 minus f of 0. Any problem, student?
Sir, how did I show that it is a root of that equation?
So it is c, the x equal to c satisfy this equation, na? Bolo, if I put x equal to c, we are getting this thing.
Yes, sir.
So that means c is a root. I think so.
Yes, sir. Yes.
Any problem? Any problem? Protusa, any problem? Protusa,
No, sir.
Komudik, any problem?
No, sir.
Next lekho. Write a homework. Write a homework. Lekho. Acha, one thing. Before writing homework, just write a note here. Acha, just tell me, if in Cauchy's mean value theorem, if I take gx is equal to x, then what are we getting? If I take gx is equal to x, then in left side, denominator is 1, then you will get f dash c is equal to, right hand side will become f of b minus f of a divided by b minus a. This is actually LMVT. So write a note here. Write a note here. in Cauchy's mean value theorem লেখো in CMVT if we take gx is equal to x, if we take gx is equal to x, then we will get LMVT, we will get LMVT. नेक्स्ट लिखो नाउ राइट होमवर्क लिखो इन CMVT for fx is equal to e to the power x and gx is equal to e to the power minus x in close interval AB, in close interval AB, so that C is arithmetic mean between A and B. Small c is arithmetic mean between A and B. You will show this. This is your homework. Next lecture. Using LMVT, we shall now use LMVT. Question lecture. This type of question important. Question is this. Do you need? I think you do not need it now. Question lecture. This question. If f dash takes number one, first question is this. Number one, if f dash takes greater than 0, if f dash takes greater than 0 for all x in closed interval AB, then show that fx is strictly increasing in closed interval AB. fx is strictly increasing in closed interval AB. We have already used this. Now I shall prove this. I prove देखो. How can I show that fx is strictly increasing? Suppose this is A and this point is B. fx is increasing money graph will be this type. So if you take two arbitrary point x1 and x2, suppose it is x1 and it is x2, then here f of x2 will be greater than f of x1. So our aim is to show that f of x2 is greater than f of x1. Lekho, I clear what I want to say? Is it clear? Is it clear?
Yes, sir.
Lekho. Let solution let x1 and x2 be any 2 points in closed interval AB and A less equal to x1 less than x2 less equal to B. A is less equal to x1 less than x2 less equal to B. देखो লেখো so here I shall show that the fx function satisfies all conditions of LMVT in closed interval x1 x2 we shall show this I লেখো number A first is this number A লেখো since f dash takes in question it is given that f dash takes exists since f dash takes exists in closed interval AB therefore therefore fx is continuous on closed interval AB and hence and hence and hence it is continuous on closed interval x1 x2 এই দেখো if it is continuous in closed interval AB then obviously it will be continuous on closed interval x1 x2 is it clear is it right bolo is it clear
Yes, sir.
yes next is number B লেখো f dash takes exist in closed interval AB so what does it mean লেখো since f dash takes exist since f dash takes exist in closed interval AB therefore f dash takes exist therefore f dash takes exist in open interval x1 x2 here I need open interval only open interval x1 x2 therefore therefore fx satisfies therefore fx satisfies all conditions of Lagrange mean value theorem in closed interval x1 x2 therefore there exists at least one value of x say small c in open interval x1 x2 such that such that well, such that such that f of x2 minus f of x1 divided by x2 minus x1 is equal to f dash c. This is by Lagrange mean value theorem and it is given in question. It is given in question that f dash takes দেখো f dash takes is greater than 0. So it is greater than 0. So this will give you after cross multiplication we are getting f of x2 minus f of x1 greater than 0. So this implies f of x2 is greater than f of x1. So f of x2 greater than f of x1 and here x1 and x2 are arbitrary. লেখো since x1 and x2 since x1 and x2 are arbitrary in close interval AB, in close interval AB. Therefore, fx is strictly increasing. Therefore, fx is strictly increasing in close interval AB. Any problem, student? Any problem? Any problem?
No, sir.
Very good. No problem. Now I shall give you three homeworks. Three homeworks. I just look at the board. Right homework you will do. Number two, second is this is your homework. Lekho. If f dash takes number two, this is your homework. Number two, lekho. If f dash takes is greater equal to 0, if f dash takes greater equal to 0 for all x belongs to closed interval AB, then show that fx is increasing in closed interval AB. I look at the board. What will be changed? You will proceed in same way. What will be changed? Just in this step here, we will write f dash c greater equal to 0. So here we get greater equal to 0. Here we get greater equal to, and everything same. Is it possible to do? Is it possible to do?
Yes, sir.
Yes, sir.
Third homework bolo. I just tell me if f dash is less than 0, then what will you get?
Sir, f of
F
Strictly
x
dash takes
decreasing.
is greater than f of
bolo.
x2. Sir, f of
Na
x1 is
f
greater
dash f of x1 greater than x2 you will get here. But what will be question here? F dash takes less than 0 mane fx is bolo.
than strictly
Fx is
decreasing.
strictly decreasing, and in as same you will proceed in same way. So what will be changed? Just here we shall write f dash c less than 0. Here it is given. So this will be less than 0, f of x2 less than f of x1. So in this diagram, f of x2 is less than f of x1 mane curve this type. So this is strictly decreasing, Taina. I clear? Apurva, is it right? Apurva, is it right? I lekho. Devpriya, is it clear?
Yes, sir.
Devpriya? Okay. So speaker, any problem?
No, sir.
Sumedha, Sumedha, any problem? Sumedha, are you here? Oh, Sumedha, sorry. Sumedha has already done this thing. Sorry. Sumedha is not here. I therefore, so this is your homework. I next lekho, another thing. Number number three. This is your homework. Number three lekho. If f dash x is less than 0 for all x belongs to close interval AB, then show that fx is strictly decreasing in close interval AB. In close interval AB. Number four, also homework. Number four, this is your homework. Number four, lekho. if f dash x is equal to 0 for all x in closed interval AB, then so that fx is equal to constant, fx is constant function, fx is equal to constant. And what will be changed here? Here f dash x is equal to 0. So you will write this here f dash c is equal to 0. So this will give you is equal to 0. This will be equal to this. So f of x2 is equal to f of x1. So in the diagram, what will be this? F of x2 is equal to f of x1 means this height is same. So height same means it is constant. I Ankona clear? Ankona, is it right? I bolo. I clear, student? Pratusa, any problem?
No, sir, clear.
Pratusa?
Yes, sir, clear.
So you can do it. Okay? You can do it. This is your homework. Supi, any problem?
No, sir, clear.
Chirag, any problem?
No, sir.
No. Okay. So you will do this. Okay? Every sentence remains same. Just change will be here. Just you will change these three steps and everything remains same. Now write this question. We shall do it now. Number 5. Number 5. Lekho. If g dash x is equal to h dash x for all x belongs to closed interval AB, then so that g of x is equal to it is hx plus some constant. I do it, do this sum. I shall give you 2 minutes time. Do it now. Do it. I do this. I shall give you 2 minutes time. Do it. Do it. Within 2 minutes, you can do it. I done, student. Have you done it?
Yes, sir.
Have you done? Complete. Very good. Well, how have you done? All of you,
So
I have to do it or not?
integrating both
Bolo.
sides with respect to x, and then we have integration d dash x dx and integration h dash x dx. So the required answer will be
Your answer is right, but you will not get any number. You
y.
have to do. You have to do actually in this method what I have done in this way. Your answer is correct. You have done this in class 11, 12. This was very important question in class 11, 12. You have done this, but here you have to show this by LMVT. Have you done anyone using LMVT? Chirag, have you done?
No, sir. Doing
Chirag,
it.
have you done? Any others?
Sir, Sparsh
Aili,
has
have you
done it.
done? Aili, have you done? Aili, have you done? Deepayon, are you here? Deepayon, Deepayon is not doing class. Judith, Judith, are you here?
Yes, sir. I'm
Bolo. Kausali, have you done? Kausali,
No, sir, I'm doing.
Samruddhi, have you done? Samruddhi, Samruddhi, have you done? Sumona, are you doing? Sumona,
Yes, I'm here.
okay. Have you done it? I দেখো, you have to proceed in this way. Look at the board. Look at the board. দেখো, here I shall consider number 5. You have to do in this way. Let 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 fx is equal to this is gx minus hx in closed interval ab. Let fx is equal to gx minus hx in closed interval ab. দেখো, so what is f dash x? Then f dash x is equal to this is g dash x minus h dash x. And in question it is given that g dash x is equal to h dash x. So it is 0 for all x in closed interval ab. And we have done sum number 4. We shall copy here sum number 4. This is, you have to show this. This is question number 4. Question number 4, you have to show this. Question number 4, we have done here the fx is equal to constant. You have to show this. You have to write the solution. So this implies fx is equal to constant. Fx is equal to constant. This is equal to k. Now this will give you fx money, it is gx minus hx. This is equal to k. So this will give you gx is equal to hx plus some constant k. I clear? I clear, student? I clear?
Yes, sir.
You have to do in this way. You have to do in this way. Okay. Next Leco. Next Leco. Question is this. Like, is Lagrange mean value theorem, is LMVT applicable for the function? Question is this. Is LMVT applicable for the function fx is equal to this function fx is equal to it is x into sine 1 by x when x not equal to 0 and is equal to 0 when x equal to 0 and if applicable then find value of c if applicable then find value of c লেখো find value of c question solution লেখো number 1 I first we shall check whether all conditions of LMVT are satisfied or not. Here fx is equal to this function. দেখো when x not equal to 0 function is continuous. But at x equal to sorry sir I have not written in the interval I question complete karo sorry in close interval minus 1 1 in close interval minus 1 1 minus 1 1 I lecco number a first is this solution lecco fx is continuous fx is continuous when x not equal to 0 when x not equal to 0 now at x equal to 0 you have to check the continuity separately lecho at x equal to 0 at x is equal to 0 what are you getting at x equal to 0 we shall check continuity at x equal to 0 lecho we shall use definition let epsilon greater than 0 be any number let epsilon greater than 0 be any number so mod of fx minus f of 0 this is equal to what are you getting mod of fx minus f of 0 is equal to it is x into sine 1 by x minus f of 0 is equal to 0. So this is we have done value of sine function will be less equal to 1. This is less equal to modulus x. Since mod of sine 1 by x is less equal to 1. Now this is less than epsilon. It is less than epsilon if modulus x is less than epsilon. Let delta is equal to epsilon. Let delta is equal to epsilon. Therefore, modulus of fx minus f of 0 is less than epsilon whenever mod of x minus 0 is less than delta greater equal to 0. Therefore, fx is continuous. Therefore, fx is continuous at x equal to 0. So fx is continuous at x equal to 0. Here we have done fx is continuous when x not equal to 0 and we are getting it is continuous at x equal to 0. That means it is continuous at any point between minus 1 and 1. Lekho. Therefore, fx is continuous. fx is continuous on close interval minus 1 1 on close interval minus 1 1 লেখো নাও ডিফারেন্সিয়েবিলিটি চেক করো লেখো নাম্বার বি here fx also f dash x is equal to দেখো when x not equal to 0 we will get f dash x easily লেখো when x not equal to 0 when x not equal to 0, f dash x is equal to its derivative is this is sine 1 by x plus x into derivative of sine 1 by x money it is cos of 1 by x cos of 1 by x this into minus 1 by x squared so this is equal to sine 1 by x minus x into minus 1 by x into cos 1 by x which exists I lecco which exists because here x not equal to 0 that is why this value exists which exists next lecco when x equal to 0 what are you getting when x is equal to 0 then find derivative f dash 0 is equal to what are you getting f dash 0 is equal to limit h tends to 0 it is f of 0 plus h minus f of 0 divided by h this is equal to limit h tends to 0 this is h into sine 1 by h whole divided by h that is limit h tends to 0 it is sine 1 by h and this value does not exist which does not exist which does not exist and you have to show this by sequential approach. You have to show this by sequential approach. We have already done in previous semester. So show this by sequential approach which does not exist. So therefore, there is a point at which derivative does not exist. So what does it mean? That means fx does not satisfy therefore fx does not satisfy the conditions of LMVT conditions of LMVT. I clear student clear I clear any problem Devpriya, do you have any problem? I please
No,
respond.
no.
Otherwise, okay. Next leco. Have you done this type of problem in your college or not? Have you done it?
Sir, we have not done so many problems. We have done one or two problem from LMVT and CMVT.
So, next level question leco. Next leco heading down. Alternative form of LMVT. This is very important. Leco. Alternative form of LMVT. This is very important. In LMVT, suppose this is A point, this is B point. If h is length of this interval, h is length of this interval, then b is equal to, we can write it a plus h. b is equal to a plus h. We can write it. What was LMVT? The f of b minus f of a divided by b minus a is equal to f dash c. This was LMVT. Now I shall put here this value b is equal to a plus h. Then what are we getting? We are getting this thing f of a plus h, f of a plus h minus f of a whole divided by h is equal to, here C is any point between A and B. C is any point between A and B. So I can write here C in this way. C is equal to, it is A plus some theta into H, where 0 less than theta less than 1. এই দেখো, if theta is equal to 0, if theta is equal to 0, value of C is A, and when theta is equal to 1, value of C is B. So for theta is equal to 0, C is here. For theta is equal to 1, C is here. So since C is not A and B, that is why theta is not 0 and 1. So I can express C in this way. C is equal to A plus theta H. Any problem here? No problem. So write it here. So F dash C money, we can write it. It is F dash A plus theta H. A plus theta H. Then after cross multiplication, we can write it f of a plus h is equal to, this is f of a plus h into, it is f dash a plus theta h, a plus theta h. This is very important form. F of a plus h is equal to f of a plus h into f dash a plus theta h. This is important form. This is the alternative form. Next, देखो, in particular form. In particular, if a is equal to 0 and h is equal to x, then what are you getting? Then what are you getting? This is f of 0 plus x, money it is fx is equal to, it is f of 0 plus x into f dash theta x, f dash theta x, where 0 less than theta less than 1. এই দেখো, here interval is, in this expression, interval is a to a plus 8. And in this expression, interval is 0 to x, 0 to x. So when you have to use, when in question you will get this type of interval 0x, you will use this formula, and otherwise you have to use this formula. So this the particular form is very important. क्वेश्चन लिखो, क्वेश्चन लिखो, क्वेश्चन लिखो. Prove the following. Prove the following. Prove the following. We shall prove this. Question लिखो, question लिखो. Prove the following. Number 1. First question is this. Number 1. Number 1. This is x divided by 1 plus x is less than, it is log of 1 plus x is less than x for all x greater than 0. x divided by 1 plus x is less than log of 1 plus x is less than x for all x greater than 0. We shall prove this by using LMVT. LMVT means this particular form here I shall use. Lekho solution is this. Lekho let fx is equal to log of 1 plus x in close interval 0x in close interval 0x. Then fx is a log function is continuous. It is not continuous when 1 plus x is less than 0. That is 1 is less, that is x is less than minus 1. X is less than minus 1. So x is less than minus 1 is not possible because interval is 0 to x. Lekho fx is continuous. Fx is continuous on close interval 0x. On close interval 0x. Then f dash x is equal to 1 divided by 1 plus x. Lekho which exists in open interval 0x, which exists in open interval 0x. Therefore, there exists theta. Therefore, there exists theta where 0 less than theta less than 1 such that this formula such that fx is equal to it is f of 0 plus x into f dash theta x. F of 0 is equal to x plus f dash theta x. This implies, now put all values. This implies fx mane 1 divided by 1 plus x is fx mane it is log of 1 plus x. We are getting this thing log of 1 plus x is equal to f of 0 mane log 1 is 0 plus x and f dash theta x here. So it is 1 plus theta into x. 1 plus theta x. Now, our question is to show that log of 1 plus x lies between this and this, and log 1 plus x money this thing. So now step by step I shall show that x divided by 1 plus theta x lies between x by 1 plus x and x. We shall show this step by step. Hai lekho. Since this is number one, since 0 less than theta less than 1, therefore I step by step we shall bring this term. So first multiply by x. So 0 less than theta into x is less than x. And here inequality remains same since x greater than 0. Now add 1. So this implies to add 1. So 1 is less than 1 plus theta x is less than 1 plus x. So this will give you, I take reciprocal, then 1 is greater than 1 divided by 1 plus theta x greater than 1 by 1 plus x. And in next step, multiply by x. So what are you getting? I next line lekho. So it will become x. This will become x by 1 plus theta x. It is x divided by 1 plus x. And here actually this value money, log 1 plus x, log 1 plus x. So final conclusion is this. Lekho, this implies x is greater than, it is log of 1 plus x whole divided by the whole greater than x by 1 plus x for all x greater than 0, for all x greater than 0. This type of sum is very important for your exam. Very important. Have you done?
Sir,
Artizman, have you done it? Bolo, bolo.
sir, if we are not told to use LMVT, then we can do it by decreasing function. Like we can take fx equal to log of 1 plus x
We have
minus.
done, yes. But
So if
it
it is
will be
not mentioned,
mentioned in your questions. It will be mentioned. Otherwise, there are two or three process you can do. I have done this type of problem in semester one also.
yes, sir.
And at that time, I have used increasing decreasing function, property of increasing decreasing function. But in this semester, they will mention. Okay.
Okay, sir. Thank you, sir.
I next, next question, level number two. Second question is this. Number two. Let number two. Second is this. Number two. So that so that this thing 0 is 0 less than 1 divided by log of 1 plus x minus 1 by x is less than 1 for all x greater than 0. So here we shall show that this value lies between 0 and 1 for all x greater than 0. How can I show this? I just very important. This is very important to note here. I therefore, if you have to prove anything lies between 0 and 1, if you have to prove anything lies between 0 and 1, then always try to prove that this value will be theta. We know that theta greater than 0 less than 1. So always we shall try to prove that this value is equal to theta. This value is equal to theta. Now, we shall continue the previous problem. Just you will take same function log of 1 plus x, same function log 1 plus x, and you will copy up to this. I mark karo and then you will copy this. You will copy it later. Dekho, this is this part. So first from starting to this part you will copy. Now from here find value of theta. Dekho, so what are you getting value of theta? So this implies take reciprocal 1 divided by log of 1 plus x is equal to, it is 1 plus theta x divided by x. that is equal to, it is 1 by x plus theta. So this implies, take 1 by x in left side. So 1 divided by log of 1 plus x minus 1 by x is equal to theta. And next write this thing. The since, I like here, since 0 less than theta less than 1, therefore 0 less than 1 divided by log of 1 plus x minus 1 by x is less than 1 for all x greater than 0. For all x greater than 0. I clear, student? Is it right? Is it right?
Yes, sir.
Any problem? I next lekho. Number 3. Number 3. Bolo.
Sir, how will we understand that we have to start from the assuming fx equal to log 1 plus x?
Okay, I shall do one thing. This log. Just try to do this sum. It will be clear, I think. I lekho. Question lekho. Lekho. Question is this. Prove that 0 is less than 0 is less than 1 divided by x. It is log of e to the power x minus 1 by x is less than 1 for all x greater than 0. I follow. From where you will start, what is your fx? You have to first choose fx, then you can proceed. Na? What will be fx? Follow anyone, please. What will be fx? First, you have to choose fx, then you can proceed. Can you say anyone?
The log function.
Can you?
Log e to the power x minus 1 by x.
Any other suggestion? Any other suggestion?
So x by e to the power x minus 1, like log of that.
अच्छा, देखो, अच्छा step by step. देखो, I don't write. Look at the board first. अच्छा, if we take fx is equal to 1 by x into log of e to the power x minus 1 by x in close interval 0x, then is there any problem? Is there any problem? Bolo. You have to check whether fx satisfies both the conditions of LMVT in close interval 0x. Is the function fx satisfies both conditions?
No, sir, it is discontinuous at
No,
0.
sir.
Discontinuous at x equal to 0, তাই না? It is not continuous at x equal to 0. Why not continuous?
1
Why
by
not
x.
continuous? বলো? Because of presence of 1 by x. Acha, if we remove this part, if we remove 1 by x and then 1 by x, if we remove this part, then then is this fx satisfies all conditions?
No, sir. So then also it's log of 0, which is undefined.
At x equal to 0 point, this value is log of 0, which is not defined. So that means first condition of LMVT is not satisfied. So why not satisfied? For which function it is not satisfying? Due to presence of log function, তাই না? Log 0, that is undefined. So if we remove log, then is it continuous in closed interval 0x?
Yes, sir.
And it is now continuous. So we shall start from fx is equal to e to the power x minus 1, e to the power x minus 1 in closed interval 0x. Is it clear to all of you? Is it clear?
Yes, sir.
Bolo?
Yes, sir.
Now start. So fx is equal to e to the power x minus 1 in closed interval 0x. Lekho. Then fx is continuous. Lekho. Then fx is continuous. fx is continuous on closed interval 0x. F dash x is equal to e to the power x. This exists in open interval 0x. 0x. So both the conditions are satisfied. Both the conditions are satisfied. Lekho. Therefore, there exists theta where 0 less than theta less than 1. This condition is very, very important. If you do not write this condition, then you will not get any number. So 0 less than theta less than 1 such that this function the fx is equal to f of 0 plus x into f dash theta x, f dash theta x. So what are you getting? Well, this will give you fx মানে it is e to the power x minus 1 is equal to f of 0 মানে it is 0 plus x into f dash theta x মানে here f dash x is equal to this. So f dash theta x মানে it is e to the power theta x. So this will give you it is e to the power x minus 1 divided by x is equal to e to the power theta x. This will give you take log. So log of we shall try to show that this value is equal to theta because it lies between 0 and 1. So log of e to the power x minus 1 by x is equal to theta x. Divide by x, you are getting 1 by x into log of e to the power x minus 1 by x is equal to theta. Next, since 0 less than theta less than 1, therefore 0 less than 1 by x log of e to the power x minus 1 by x is less than 1 for all x greater than 0. For all x greater than 0. Next question lekho. Next lekho. Find approximate value of root 51. Find approximate value of, question is this, find approximate value of root 51. We shall find its approximate value. Here, here we shall use this result. first you have to choose fx function. And what will be here fx function? You have to choose fx a and h. Lekho, let fx is equal to root x, and we shall choose a in such a way that easily you can calculate value of root a. So nearest value of 51 whose root is easily calculated is 49. So I shall take a is equal to 49 and their difference is 8. Is it clear to all of you? Is it clear?
Yes, sir.
Yes, sir.
Yes. Very good. So here interval become, what is the interval then? Here interval is actually 49 to 51, this interval. So in this interval, first you have to state whether fx satisfies all conditions of LMVT or not. Lekho, fx is continuous. Fx is continuous on closed interval a to a plus h. Here fx will be not continuous when x is less than 0. But in this interval, there is no possibility to be less than 0. So fx is continuous on closed interval a to a plus h. Then f dash x is equal to 1 by 2 into root x. F dash x is equal to 1 by 2 into root x, which exists in open interval a to a plus 8, which exists in open interval a to a plus 8. Therefore, there exists theta. Therefore, there exists theta where, where 0 less than theta less than 1 such that f of a plus h is equal to f of a plus h into f dash a plus theta h. So this implies I put all values. So it is f of a plus h, means it is 51 is equal to f of it is 49 plus h into f dash means it is, h means this is 2, sorry, h means it is 2 into f dash a plus theta h means here it is f dash a means it is 49. This is 49 plus 2 theta. 49 plus 2 theta. I try to simplify this. What are you getting? So root of 51, f of 51 means it is root of 51 is equal to, this will become root of 49 plus 2 into f dash means from here 1 divided by 2 into root of 49 plus 2 theta. Root of 49 plus 2 theta. This is actually 7 plus I2 cancel. It is 1 divided by root of 49 plus 2 theta. Root of 49 plus 2 theta. Here we shall approximate in this way. This approximately we shall approximate this 7 plus this is 1 by root 49. So this is equal to 7 plus 1 by 7. That is 7 into 1 by 7. This. This is the approximate value. Now write a homework. Have you done this type of problem in your college? Approximate value wala problem?
No, sir.
Yes, sir.
You have done. I write a homework. Write this homework. Lekho. Lekho. Homework. Find approximate value of sine 46 degree. Sine 46 degree. I shall give you hints. You will do this. I देखो. Here function will be fx is equal to sine x. A is equal to, we shall take 45 degree, but everything you have to write in radian. We shall take it pi by 4. And h is equal to 1 degree, which is equal to pi by 180. And then proceed. You will get result. This is your homework. Next, Lekho. Next, another sum is important. Lekho. Find approximate value of, just this question, Lekho. Question, Lekho. So that, question is this, so that 10 is less than root 101 is less than 10.05. 10.05. 10 is less than root of 101 is less than 10.05. Or question may be in this way also, so that approximate value of root 101 lies between 10 and 10.05. So we shall show this thing. Lekho. Solution lekho. Let fx is equal to root x. I just look at this part and then choose function fx is equal to root x. Can you say anyone what will be value of a and what will be h?
A will be 100.
Anyone? A will be 100. Very good. And h will be
1.
1. Very good. 1. So interval is here 100 to 101. This is your interval 100 to 101. Lekho. I check karo. Lekho. fx is continuous. fx is continuous on closed interval a to a plus h. And f dash x exists in open interval a to a plus h. Lekho. Therefore, there exists theta. Therefore, there exists theta such that 0 less than theta less than 1. You have to mention this condition such that 0 less than theta less than 1 such that f of a plus h is equal to, it is f of a plus 8 into f dash a plus theta into h. Now put all values. So this will give you, it is root I f of 101. It is f of 101 is equal to, it is f of 100 plus 8 money, it is 1. It is f dash a money 100 plus theta. So this will give you root of 101 is equal to root of 100 plus f dash money what I have not done. I f dash is equal to, here I just you will write here f dash x is equal to 1 by 2 into root x na. F dash x equal to 1 by 2 into root x which exists in open interval a to a plus h. So f dash x equal to 1 by 2 into root of 100 plus theta. So this implies root of 101, root of 101 is equal to, it is 10 plus 1 divided by 2 into root of 100 plus theta. This is number 1. This is number 1. Next, therefore, we shall show that this value is greater than 10, less than 10.05. Lekho, since 10 is less than 10 plus 1 by 2 into root of 100 plus theta. Therefore, obviously it is positive. So therefore, we can say that 10 is less than this value money actually root 101. Root 101. This is number 2. Is it right, student? Is it clear? Is it clear?
Yes, sir.
Okay.
Very good. Next Leko. Next Leko. So this is number 2. Now that means first part we have already proved. First part already proved. Now we shall prove the second part. Prove karo. Sorry. Second part that. Sorry. Second part is this. Next. We can say this thing. देखो 1 by देखो 1 by 100 plus theta is clearly less than 1 by 100. 1 by 100. देखो since theta greater than 0. And now take root. So root of this, next line, root of 100 plus theta will be less than 1 by 10. We shall multiply next line, just multiply by half. So 1 by 2 into this will be less than 1 by 20. 1 by 20. Now add 10. So this implies 10 plus something is equal to 10 plus this. 10 plus this. 10 plus this. So this is equal to, this value is equal to, this implies, left hand side is root of 101 is less than right hand side is 10.05. This is number 3. Lekho From 2 and 3 we get, what are we getting? From 2 and 3 we get this thing, 10 is less than root 101 is less than 10.05. Any problem, student? Any problem?
No, sir.
Very good. Next Pleco. Next Pleco. Have you not done this type of problem in your college?
No, sir.
We have not done.
You have not done. And which department not done?
Sir, physics.
Sir, eco also not done.
So what are you doing from this chapter? Rolle's theorem, Lagrange theorem.
So Taylor series expansion mainly.
Different chapter, so different thing. Taylor's Maclaurin expansion, so different thing. From Rolle's Lagrange mean value theorem, what you have done then?
Sir, not much sums we have done, sir. It's just total the proof and one, two sums.
Sir, only the proof and 1 and 2 basic sums.
Okay. Now this type of sums are very important. This type of sums very important. And next Pleco. Next Pleco. In the mean value theorem, question is this, in the mean value theorem, f of h is equal to f of 0 plus h into f dash theta h, 0 less than theta less than 1, so that this limit h tends to 0 plus, limit h tends to 0 plus, theta is equal to 1 by 2, where fx is equal to cos x, Here it is given that fx is equal to cos x, and relation of alternative form of LMVT is given. You have to show that limit h tends to 0 plus theta is equal to 1 by 2. Try to do this. Try to do. Well, how can we proceed? Here function is given. What is the interval here? What is the interval? Anyone please? 0 to h, তাই না? 0 to h. A মানে তো 0 here. So interval is 0 to h. In this interval 0 to h, cos function is continuous. Cos function is always continuous. লেখো fx is equal to cos x is continuous. Fx is equal to cos x is continuous. On close interval 0h, and f dash x is equal to minus sin x, which exists in open interval 0h. Therefore, there exists theta where 0 less than theta less than 1, such that f of h is equal to f of 0 plus h into f dash theta h. So this will give you, I put all values. F of h মানে it is cos of h, f of 0 মানে 1 plus h into f dash theta h মানে it will be minus of sin theta h, minus of sin theta h. So this will give you h into sin theta h is equal to 1 minus cos h. So we shall write in this way, sin theta h is equal to 1 minus cos of h divided by h. We know the standard formula, the sin x by x, this limit is 1. We shall use here. So sin theta h divided by theta h into theta h karo. This will give you 1 minus cos of h divided by h, divided by h. Now this will give you, I divide by this h, so theta into sin theta h divided by theta h is equal to, it is 1 minus cos h divided by h square. Now take limit on both sides. So this is limit h tends to 0 plus, it is theta, this is sin theta h divided by theta h is equal to limit h tends to 0 plus, this will be 1 minus cos of h divided by h square. So this will give you, I write bracket here, this will give you, what are you getting? This is limit h tends to 0 plus, limit h tends to 0 plus, it is theta, and this limit will become 1. This limit is 1 is equal to, here you have done in class 11, 12, L Hospital's rule. I shall use here L Hospital's rule. I দেখো, this value is, if I put h is equal to 0, denominator, numerator both are 0 and 0. So it is 0 by 0 form. Then differentiate karo both denominator and numerator. So it is limit h tends to 0 plus, this will become sin h divided by 2h. I can take these two outside the limit, and then sin h by h, this limit is 1. So ultimately we are getting limit h tends to 0 plus theta is equal to 1 by 2. I clear, student? Any problem? No problem, I think. No problem. Now, so Rolle's theorem, Lagrange theorem, and Cauchy's mean value theorem complete. Now, just I shall start expansion of function. Just we shall start. We shall do it in next class. I bolo, when do you have math exam? Do you know about your date?
Yes, sir. Sir, it's 23rd.
23rd. 23rd mane which day?
Sir,
Thursday.
Thursday.
Tuesday.
Sir, Thursday.
Thursday is your math exam, and what first exam is on which day?
20th, Monday.
20th Monday is the first exam. Oh, acha. So that means in next Monday you cannot do class, na? So yeah, I don't know. So that means it is for Monday batch. So I shall take, please arrange one class before Monday. I shall do expansion of function. I need a total one class to do this. Expansion of five functions are there. E to the power x, sin x, cos x, log 1 plus x. These are mainly important. So I shall inform you in the group. Try to do it either on Wednesday or Thursday, any one day. I shall inform you in your group. Otherwise, not possible to do. I just look at the board just 2 minutes. So just we shall start. We need this thing. We need this thing. Just result lekho. We shall use this result in next day. We have done successive derivative in previous semester. So in this semester also I need this. I shall use this successive derivative. Successive derivative. I দেখো these successive derivatives I need. Number one, first is this. If fx is equal to e to the power x, then its n time derivative, if this, then its n time derivative will be equal to e to the power x. And then its value of derivative at x equal to 0 will be 1 for any value of n. Number two, second is this. I follow what is sine x? What is about sine x? If fx is equal to sine x, I shall use it in next class. Fx equal to sine x, then its n time derivative at x is equal to, this is sine 2n pi. What was the formula বলো তো? Sine 2n pi নাকি না sine n pi? I think this will become sine n pi plus x, na? Is it right? Is it right what I have written? Sine n pi by 2, I think, sorry, n pi by 2 plus x. So this implies fn0 is equal to, this will become sine n pi by 2, sine n pi by 2. Similarly, if fx is equal to cos x, then fn x is equal to, its n time derivative will be same thing. Cos of it is n pi by 2 plus x. So this implies fn0 is equal to, it is cos of n pi by 2, n pi by 2. Number four, this function, mainly these functions are important. If fx is equal to log of 1 plus x, if fx is equal to log of 1 plus x, then fn x is equal to, then fn x will be equal to, formula is this, minus 1 to the power n minus 1. It is n minus 1 factorial, n minus 1 factorial divided by 1 plus x whole to the power n, whole to the power n. And we need fn at 0 is equal to, fn0 is equal to minus 1 to the power n minus 1 into n minus 1 factorial. Fn is equal to this. Another very, very important result is this. Lekho, if limit n tends to infinity, mod of un plus 1 divided by un is equal to L, which is less than 1. If this limit is less than 1, if this limit is less than 1, then what does it mean? Then un tends to 0 as n tends to infinity, as n tends to infinity. So these are the important results what I shall use in next day. Next day, we shall use this result. Very, very important result. So we shall do next day Taylor generalized mean value theorem with general form of remainder, and then Maclaurin's theorem with remainder. There will be two types of remainder: Lagrange form of remainder, Cauchy's form of remainder. And we shall do infinite series expansion of these functions. We shall do it in next day. Okay. Have you done infinite series expansion of these functions?
Yes, sir.
Yes.
Done, na? Okay.
Yes, sir.
Okay. Okay. We shall do it in next day. So keep till here. These are very long problems. Okay. Thank you, student. Thank you all. Thank you all. Thank you very much.
Thank you, sir.
Thank you, sir.